All right, Section 4.5. This is systems of linear inequalities. So this builds on a couple of different things. One, it really builds on some stuff that we did at the end of Chapter 3 where we're graphing inequalities. And in inequality, when you graph it, it looked like this, where we had our y-axis and we had our x-axis, and then we might have a dotted line like this. And our job was to color either the top part or the bottom part because we had to pick a ordered pair and to see if it worked. This is just a very general overview. We talked about this a lot. And this was what the solution to that inequality, say that the inequality was y is less than, I don't know, 3x plus 5. I'm just making that up. So if that was what it was and we graphed it, it may look something of this nature. This doesn't mean that it's right, but for the most part, this is what we're doing. Okay, so a system of linear equalities is actually where you have two or more of these, and your job is to solve for it. And the solution works like this. It's an ordered pair that is a solution to each inequality in the system. Note, here's the thing. There's actually an infinite amount of solutions here. There's an infinite amount of possible ordered pairs. But our job is just to kind of figure something out. So let's give you just a kind of a little bit of an example. Here's a small system of linear inequalities right here. We want to know, is this ordered pair a solution to this system? And the way we do it is we plug these ordered pairs into not one, but both of these to see if it's true. So I'm going to put 3 in the place here. So we're going to just kind of do some work on the side here and write these both down again. And we're going to plug numbers in. Y is 5, so 5 is less than 2 times 3. Y is less than 6. All right, now let's do the other one. 5 is greater than or equal to 3 plus 1. 5 is greater than or equal to 4. This is a true statement, and this is a true statement. So this is a solution. So this ordered pair is a solution for this system. But here's the thing, it's not the only one. Just keep that in mind because that's very important here in a few minutes. So now let's look at this one. Is this a solution? So we're going to do the same thing. Y is less than 2x. Y is greater than or equal to x plus 1. We're going to plug numbers in. 0 is less than negative 2. And then the next one would be 0 is greater than negative 2 plus 1. 0 is greater than or equal to a negative 1. So is this a true statement? No, this is not a true statement. It's not a true statement at all. Is this a true statement? Yes. But here's the thing. Even though this one is true, this one's not. So this is not a solution. So in other words, this number right here will not solve this system at all. And just like I said before, though you have an infinite possible amounts of possible ordered pairs that are solutions, you also have an infinite amount that are not solutions. All right, so let's go ahead and start putting this in. The reason why I'm showing you this is because it helps us actually to graph this, and that's what we're going to do. You are going to graph a systems of linear inequalities. So your job, just like we did in Chapter 3, is we're just going to graph this. That's the first thing I want to do. So we're going to graph this first one. It says y is greater than or equal to a negative 1. So right off the bat, I realize that this is going to be a solid line because it says equal to in it. So I'm going to draw a solid line. And also because I know the rules when it comes to graphing lines, that this is just a y is greater than or negative 1. I'm actually going to create a horizontal line on negative 1. So let's do that. Okay, so there's my first inequality, but I need to decide now, do I color the bottom half or the top half? So what do? just like in chapter 3, I told you the best thing for you to do is to use your origin point. It just makes things nice and easy. It's right there. So I know my origin value is always going to be 0, 0. So in this case, y is going to be 0. So let's plug that in. 0 is greater than or equal to -1. Is that true? Is 0 greater than or equal to -1? Yes, it is. So I can actually color this top half. And what I'll do is I want to use, get my color pencil here. I want to use my color pencil so we can see it. So we're going to color this entire half blue. All right, so I've graphed the first inequality. So the next piece that I need to do is to graph the second one. And I graph it just like I normally would a line, but this time, since this doesn't say equals to, I need to use a dotted line. So we're going to use our slope-intercept form. We are going to start at a +2, and then it has a slope of +2 over 1. So we're going to go up 1, 2, and over 1. So those are my 2 points. I am going to draw my line. Okay. All right. So now, oops, I messed up. I didn't mean to do that. Shouldn't have drawn a solid line. It needs to be a dotted line. Okay. So I'll just kind of fix it just a little bit. It's a dotted line. All right. Now, do I color to the left side or the right side? Well, just like before, I can use my origin, because notice how my line didn't go through my origin. So I can use 0, 0 again, and I can say 0 is greater than 2 times 0 plus 2. Simplifies that. 0 is greater than 2. Is that a true statement? No, it's not. So that means that I can't color the bottom piece, or the right side, I can only color this side. And notice that I'm coloring this side because all of these are infinite possible answers. Now, with that said, what do you notice? You should notice this, that they crossed paths. And they crossed paths right here. Now I'm going to kind of darken this up just a little bit, just to show the color difference. So basically, red and blue made purple. This is how my solution works. This is the solution to this. So any point that's in this dark shaded region right here will work for either one of these. So I could pick this one and it will work for both of these inequalities. I could pick anything up here, it will work. But if I choose this one, it will only work for the one here. If I choose a point from here, it will only work for the points here. If I choose a point from here, it won't work for either one of them. So an infinite amounts of points work in this group. So same concept will happen in number 2 and 3 and 4. So I'm actually going to let you do those on your own because this is a very simple concept. Your job is to graph these. So you may have, so this one right here, your job, use your basic skills when it comes to simplifying these and rewriting them in slope-intercept form and graph it. All right, so after doing this, probably what you did was go ahead and put everything into slope-intercept form, and you should have got these very similar equations, and this is what your graph should look like. So for number 2, you have a very small sliver that would be your possible answers here. Where over here we've got this bottom section, and then if you notice on this one, it actually never even crossed, and that's okay. They don't have to cross, so you should have gotten these. All right, and that's pretty much it. This is how you graph it. You graph it each one, and then you just basically see where they lie. All right, so number 5. Let's talk about that one. You would have at most 10 hours to study for your math and English finals. You decide to study at least 3 times as much for math as you do for English. Your job is to write and graph a system of linear equalities that represent this solution. All right, so pause right here. It says you have at most 10 hours. So right off the bat, you cannot have any more than 10 hours. So doesn't matter how many hours you study. Let's say X is math and Y is English. No matter how many hours you studied for math plus however many you studied for English, they cannot be greater than 10. So they can be less than, but they can never be bigger than 10 because you have at most 10 hours. You can have exactly 10 hours, but you can't have any more than that. And then it says you decide to study 3 times as much for math as you do for English. So, with that being said, how do we go about that? So, you want to study 3 times as much as you do for English. So we decided that X was math and Y is English. That means that you want to study 3 times as much as you do for English as you do for math. But you want to do at least that amount. So with that being said, you would have a line like this. Now that we've kind of discussed what our graphs look, our lines are, your job now is I want to let you graph it. So it's asking, is it possible to study 7 hours for math and 3 hours for English in this situation? Justify your answer. So why don't you finish graphing this and then do B on your own, and then come talk to me if you got any problems. That's it for this video. That is actually the end of chapter 4. And we've got a test coming up here soon. And as always, ask questions, and I will see you in the next video. Bye-bye.